Hi guys, this is Edward, and welcome to this third video tutorial. So, taking the project from where we left off. In the previous video I said that when the rotation of the bird is bigger than 30, we will set it to 30, and the angular velocity is set to 0 as well. But I actually forgot to set the velocity to 0 in code. And it's still working because as soon as the bird starts falling, we set the angular velocity to 1.5. But just to be sure, I'm going to still set it to 0. And it works just as before. So we have been working with the vertical velocity so far, but not with the horizontal. And this one is actually easier because the bird just goes to the right on and on. So on the ready function of the bird script, we'll set the horizontal velocity by passing a vector 2. For x, a value of 50, which is a value I have found out works really well. And for y, we will leave it as it is by setting its same value. And now we have the bird going to the right, but it's also getting out of view. So we have to use a camera 2D node, but we won't create it here in the bird scene, because this scene is only meant for bird related things, and that wouldn't make too much sense. So from now on, we are going to be running the game stage scene, which is going to contain a camera 2D node, and we already know how to create a new node. Just make sure to create it as a child of the main node. Search for the camera 2D, and there we have it. Now the view of the camera is centered to its position, but for this game, it's better to take the position as a top left anchor. Unfortunately, there is already a property named anchor mode. By default, it's set as drag center. Let's set it at fixed top left. And this camera won't have any effect on the view unless we set it as current. This is useful if we are using more than one camera and we want to switch between them, but we are just going to use one in this scene. To see if it is working, let's place the camera somewhere, and the view shows the outline we see here. Let's hit Ctrl C to do it. So to get the bird we have already created, here in the game stage scene, we are going to create an instance of the bird scene. And to instantiate a scene, we just have to click on the plus icon here and select the scene we want to create an instance of. In this case, it will be the bird scene. And make sure you instantiate it as a child of the main node. We can tell when a node is an instance for this icon that appears. By clicking on it, it displays a few options. Editable children allow us to see and edit the children of this instance. Keep in mind that changing any property of this node or any of its children won't affect the original scene, only this instance. And that's what instantiating is all about, which is really handy. And we can set a change value to its default value by clicking on this little arrow icon, which is also really useful if we want to see what properties has been changed on this instance. And even if we add a node to the instance, it won't affect the original scene or any other instances. And it's worth mentioning that we can't delete a children that have been created on the original scene, although we can change its properties, and of course delete a node that was created in the instance. Other option we have is to set an instance as a placeholder, which means that it will appear in the editor, but it won't appear during runtime. Instead, a placeholder will take its place, so we will have to load the instance manually from code. I personally haven't used it, but I'm pretty sure that's what it does. And lastly, we have a short way to open the original scene, which is very handy. So I'm going to disable editable children, because we won't be editing this instance. We are just going to use it as the original scene. And let's try out the scene to see if it is working. And the bird does its thing. So we want to make the camera follow the bird horizontally, and we can't just set the camera as a child of the bird, because that will affect not only the X position of the camera, but also the Y position. And it gets really messed up because the bird is rotating. So we'll have to do it from a script. let's add a script to the camera. Save it in the script folder as camera.gd. I'm going to clean the script and enable the fixed process function. And on this function, we're going to set the position. For x, we want the x position of the bird, and since this script is in the camera node, we'll have to find a way to get the bird node, and there is actually a function named getNode, and the autocompletion will show us the children of the camera, but this doesn't have any, so it only shows a point. What we are going to do is to go one node up, and we can do it by using two dots. And to get one of its children, we just have to type the slash and the name of the node. Now that we have the bird, we can get its position on the x-axis. And for the camera y position, I'm just going to leave it as it is. Now, instead of looking for the bird node in the fixed process, we can declare a member variable named bird and store a reference of the bird node in the ready function. We can't just assign it here where we're declaring the variable, because when this runs, the scene tree is not already yet, and we are searching for a node, so this will probably return null. So we can either assign it here, or type the keyword on ready before declaring the variable, and that makes sure it gets assigned once the node is ready. So we can delete this one. And now we can use the verb reference to get its position, and that gives us not only a more clear code, but also a most efficient one. Let's give it a shot. And the verb gets cut off, because we are setting the camera X position exactly in the bird's position. But we can easily fix it with an offset, but instead of doing it here in the script, we can actually use a property that comes with the camera 2D node. Name offset. The X offset, I'll set it to 25% of the game view to the left, so we give the player enough room to see what's coming next, without having the bird too close to the edge. So the width view we set in the project setting is 144. To get the 25% of this, I'll multiply it by 0.25. Press enter, and it goes to the right, because this value is positive. To have it negative, I'm just going to multiply it by -1. Let's try it out. And now it's much better. I also want the verb to start at 25% of the view, but to the right. So in the verb scene, I'm going to set the X position to 0.25 times the game view. And we can see the changes in the game stage. And it kind of looks the same, just that now it starts right at this edge. So back to the camera script, we are getting the bird node by using a relative path, going a node up and then one down. So if we want the camera somewhere else later on, we will have to come back here and make sure it's still having the correct path. So I believe that it would be better if we could get the main node of the current scene without using a relative path, and then find the bird node from there. And we actually can do it. First, we need to get the scene tree, and the scene tree is kind of like the most abstract thing in the engine. What I mean is, we have a node, then its parent, and when we reach the main node of the scene, we have the root node, and finally there is the scene tree. So from the tree, we are going to get the root node. And even though we can't actually see it here, it's already been created. If we run the project, in the debugger, under the tab Info, we can see the state of the scene tree, and the first thing at the very top is the root node. And under the root node, we have the main node of the scene that is currently running, along with all its children. And since the main node is a child of the root node, we can use the function getChild, and it's asking for the index of the child. Since it only has one, we can just pass 0 as index. Now that we have the main node, instead of using a relative path, and get the verb from it, so now it won't matter where the camera is. It will always get the verb node. Let's try it out. And it's working as before. So I think that this way of getting the main node of the scene is really handy, and it would be a good idea to have it on a function somewhere. So we are going to create a scene that will be auto-loaded by the engine, and can be accessed globally. Let's add a simple node. Save it in scenes as utils.tscn. Let's rename this node as utils, and let's add a script named utils, and save it in the scripts folder. I'll clean what we don't need. And let's create a function named getMainNode, which is going to return the first child of the root node, just as we did before. Now to make this scene global, we have to go to the project settings, and under the tab Autoload, we will add the util scene. And now that we have it set up, in the camera script, we no longer need this, and we'll say instead utils.getMainNode. Let's try it out, and it throws us an error, telling us that we are calling the function getPosition from a null instance. If we go to the Info tab and refresh the scene tree until the root node, we don't only have the current scene, but also the utils node, which is what makes it global. Now the reason why we're getting an error is because in the function getMainNode, we are returning the first child of the root node, and the util scene is being added before of the scene that is running, which means that our autoloaded scene will be added before the current scene, and that's actually good, because that makes them ready for our use in the scene running. So instead of returning the first child, we have to return the last one. I'll save a reference of the root node, and we'll say instead root node.getChild, and for the index, we'll pass the root node's child count -1, so we're always getting the last child. Let's see if it's working, and we have it as before, but our code now is way more clear, and we can easily get the main node every time we want it. The next thing we'll do is create the ground scene, and for the main node here, we'll use an static body because they are not expected to move, so they don't consume any CPU resources, at least not like a rigid body. And in this game the ground never moves, so it fits perfectly our need. We will also use an sprite and a collision shape. Let's rename the main node to ground, and in the sprite node, as a texture, we're going to assign the ground sprite. Let's disable centered, so its position is relative to the top left corner, and I even want it to be relative to the down left corner, because it will make it easy to also spawn it. So in the offset property, y have to be the height of the ground sprite, and since an image is a resource, we can see its properties by clicking on edit. The height is 56. Let's go back and set that value as the y offset, and it has to be negative of course. So now I want the default position of the ground to be right at the bottom of the view. So for its y position, I will give it a value of 256. And now when spawning, we just have to worry about its horizontal position. Let's save it in the scene folder as ground.tscn. And let's also create an instance in the game stage and play it. And we have the bird and the ground not colliding each other, because we haven't defined a collision shape for any of them. So in the collision shape node of the bird scene, as a shape, we are going to define a new cycle shape. And now we have this sampled cycle showing us the shape. We can edit it by dragging this red little cycle. Make sure not to use this, because they scale the shape and that will cause conflicts with the physics. We can also edit it in the inspector if we want to be more precise. I'll set the radius to 6.5. Save it, and for the ground, we'll set a rectangle shape. You'll have the same dimension as the sprite, but divided by 2, because it's asking for the extension of the shape, and the same value for the position, so it matches with the sprite. Let's run the scene. And now they collide with each other. So now we are going to create the ground spawner scene, and this scene is going to have a node 2D as a main node. I'm choosing this instead of a simple node because it has a transform, And since we are going to be spawning the grounds in different places, we will be using this node's position as a reference. Let's rename it to spawner ground. And I'm calling it like that, instead of ground spawner, because this way keeps things more organized. Since we will have other spawners, having a spawner as a prefix makes them easier to identify, in my opinion. Let's also save it as a spawner ground.tscn. And of course, we will also need a script. Don't forget to save it in the scripts folder. I will clean this up. So to better understand how the spawner will work, we are going to have an instance of the spawner in the game stage scene, but we are going to give it an initial position right at the bottom left of the view, and from there we're going to spawn a ground. Then we're going to move to the next position and spawn another ground. Then again we will move and spawn, and we will keep doing that on and on. So there are two main things the spawner is going to do. Spawn a ground and go to the next position. And let's not forget to set its initial position at 0256, right at the bottom left. Let's now implement the spawner ground function. And to do so, we first need to grab a reference of the ground scene. I like to give it the prefix scn to the variable that contains a scene, so I can know what I am working with at a first glance. Since the ground scene is a resource on a file, we need to preload it. And of course, we already have a function to do so, and this function is asking for the path of the resource. In this case, we have it in the scenes folder under the name ground.tscn. By the way, the rest with the semicolon just represents the root directory of the project, which makes really easy to find the path of a resource or a file. And since this is a reference of a resource that we won't be modifying from code, let's have it as a constant. Now, on the spawn function, we're going to grab an instance of the ground scene. So now, we basically have the scene as a node, and we just need to add it as a child of another node that already is in the scene, to have it in the scene as well. If we don't add it to the scene tree, we're just going to have it here in the scene code. Let's just add it as a child of this same spawner ground node. And let's also not forget that the position of every new instance will be the same position of the spawner. So just before adding the new instance to the scene tree, I'll set its position to the position of this node, which is the spawner. Let's call the spawn function in the ready function to try what we got so far. And we can't see the new instance of the ground. So we are indeed giving the same position value of the spawner, but when we add it to the scene tree, we add it as a child of the spawner, so its position is relative to the spawner, which is already at the bottom of the view, and that is placing the new instance way off of the view. What we can do is to have a node here in the spawner as a container, but making sure that the container is a node in its most simple form, because they don't even have a transform, so they don't have a position either. And in the 2D view, the spawner, which is a node 2D, has a position that is displayed by this red square. But when we select the node that doesn't have it, the scene view doesn't show us anything. So a child of this node will look for its parent position, but since it doesn't have one, the position of that child won't be relative to anything. So let's rename this node to container. And in the script, instead of adding it as our own child, we'll get the node container and add it there. Let's run this scene again. And there we have it. Now for the go next position function, it's really easy actually. We just have to move the spawner 168 to the right, which is the width of the ground, from its current position. So we're gonna have a constant name ground width equals to 168. And in the go next position function, we'll set the position to its same value plus a vector 2, with the ground width as x and 0 as y, so it just stays put in the y-axis. Let's call go next position and spawn ground twice in the ready function, just to see if it is working. and we won't be able to see it here in this scene. So let's go to the game stage scene. I'll delete the ground node because we don't need it anymore. And let's make an instance of the spawned ground. Run the scene. And now we should have two grounds. It's difficult to see them, but it's large enough to tell there is more than one there. Now we know it's working. Let's get rid of this. So the next step is to make the spawner create the grounds dynamically. Let's say that we start the scene and the spawner immediately creates a ground. Since the camera is going to be moving to the right because it's following the bird, we want to destroy this ground as soon as it's out of view, and that happens when its position plus the width of the ground is less or equals than the position of the camera. Now, as soon as the ground gets destroyed, the spawner is going to spawn another one and move to its next position, and the camera is always going to be moving. So those actions are going to happen over and over. Now, if you really pay attention, there is something that doesn't quite fit, because within the view, the ground should seem seamless, but we are having a little gap here. And the solution to this is actually really simple. If at the very beginning we start with two grounds instead of just one, we won't be having that little gap again, because the spawner will always be one step ahead when a ground gets destroyed. I have added this red line at the right of the ground so we can tell between them, and when I remove them we get a nice seamless ground. So back to the editor. Let's first make sure we start the scene with two grounds. I'm going to create a constant name amount to fill view equals to 2, and this is just the amount of instances we need to avoid the little gap between spawning. So in the ready function, we're going to create a booklet for that is going to loop as many times as the amount to fill view. And in the for, we'll call the spawn ground and go to next position functions. And we have something similar as before. So now let's make the ground to destroy itself once it's out of view. Let's add a script named ground, saving it in the scripts folder. I'll clean this. And in the process function, we will say if our x position, but let's not forget that our position is at the left and we want it at the right, so we will have to increase it 168, which is the width of the ground. Now another solution will be to add a position node and place it right at the right. Name it bottom right and use it as a reference. Let's create a variable named bottom right equals to get node bottom right. And don't forget to have the keyword on ready. So here we will say if bottom right dot get global position, and it has to be the global position, otherwise the function gets position will give us the relative position to the ground itself. And if it's less or equals to the camera's horizontal global position, and in this case it won't really matter if we are using the global position or the relative one, because the camera is a child of the main node, which is a simple node without a transform, and we haven't actually declared this variable. So let's do it and set it equals to utils dot get main node get node camera. And let's also rename the camera to the node to just camera. So if this statement is true, we're going to call the function q3, which will destroy this node. Let's run the project. And there is a little gap, meaning that the ground is getting destroyed before it should. And what happens is that we have set an offset to the camera, and when we get its position, it doesn't come with that offset. So in the camera script, let's create a function named getTotalPos and return the global position plus the offset. And back in the ground script, we'll use this function. Let's run the project again. and we can't now see when they get destroyed. But if we visualize the scene tree, we can see that the container have no children. Now, if we run the ground scene by itself, we get an error telling us that the camera is a null instance, and that's because this scene doesn't have a node named camera. So when we ask for the main node, it gives us the ground node, and there is no camera in here. So if we want to make our scene really modular, we could ask here if the camera is null, and if it's so, return. So this code below won't run, and now we can run this scene. And I like to do this, so if I want to make any changes or add something new to this scene, I can test it really quickly. So now we have the ground getting destroyed. The next thing is to make the spawner spawn when that happens, and to do so we're going to use signals, and a signal is an event that once it gets triggered, we can call functions that react to that event. It's better to just do it instead of explaining it. We can create a signal using the keyword signal and then the name of the signal. I'll name it destroyed. We want to trigger this signal right after destroying the node, using the function emit signal, passing the name of our signal, and we can also send some extra information, but we don't need to send anything for this signal. Now that we have set out the signal, on the spawner ground function, for every new ground we create, we're going to connect the signal destroyed to this self node, to the spawn ground function, and also connect it to the go next position function. So when we connect a function to a signal, every time that signal is emitted, that function is going to get called. I have personally found signals really useful, and I use them a lot. Let's run the project. And now we have an infinite ground. Also notice that the bird is slowing down over time, and that is caused by the linear damp in the rigid body of the bird. The linear damp is set to -1, which means that it will use the default value used by the engine. Let's set it to 0. And now the bird keeps its horizontal velocity. I also wanted to mention that there is actually a built-in signal that gets emitted when a node is removed from the scene tree, and that signal is exit tree, so we don't need the signal destroy we created. I did it because I think that it's easier to understand signals by creating your own, and let's connect the signal exit tree instead. We run the scene and we have the same outcome. Now I have found an issue when connecting two functions to the signal. For some reason sometimes the third ground doesn't connect the functions in the right order. So it calls go next position and then spawn ground. And that makes two grounds to be in the same place and having an empty space. The workaround I have come up with is to wrap the two functions in only one. So I'll create a function named spawn and move, which will call the function spawn ground and go next position. And we'll just connect the function spawn and move. And since there is now no need of calling those functions individually, let's also use it here. And it keeps working as before. Now just before jumping into the next topic, I said in the previous video that I usually rename all the nodes, and I wanted to tell you why, and there is actually too much mystery here. It's just because GDScript uses lowercase for almost everything, and I like to be conventional with what I'm using. So for that reason, I have named all the resources and folders using lowercase. And I also do it with the nodes. So in the verse scene, I'll name these nodes to anim sprite, shape, and anim. In the game stage, I'll name the main node to world, and in the ground scene, I'll call this one sprite and this one shape. And I don't think we should get any errors. So now we are going to do the background. And this will be really simple, because the background just says put in the view. And we only need one to fill the view, so we don't actually even need a background spawner. Or at least not for now, because later we will make the game to work on every size, so you can play it on your phone or on a TV. So let's create the new scene. And I'm going to close all these others because we don't need them now. So for the main node of the background, we're going to use a canvas layer node. And what this node does is place all its children in the layer we indicate here. And not only that, this node also ignores the default viewports of the game. So all its children are going to stay put in the view, even when the camera is moving. So this node is very useful, not only for backgrounds, but also for headshot displays. So since the default layer is 0, I will set the layer of this node to -1, so it gets drawn below everything else. Let's rename it to background. And instead of adding a sprite node, since we already have a node with the background sprite, I'll show you how you can copy a node from a scene and paste it in other scene. In the background scene, we will import a node from other scene. We want it from the game stage scene, and we want to import the sprite. I'll name it to sprite with lowercase. Let's save this scene as background.tscn. And on the game stage, we can delete this sprite and insert the background scene. Let's run the scene. And now we have the background always at the back. The next thing, the pipes. Let's create a new scene and add an static body. I'll rename it to pipe. And even though we are calling it pipe, this scene is actually a column that will contain two pipes, one on top of another. So let's add two sprite nodes. Duplicate this one. Let's name them sprite top and sprite bottom. For the sprite top, we'll assign the pipe green top sprite. And for the bottom, the pipe green bottom. And one is over the other. So let's place the top at -101 on the y-axis, and the bottom one at 101. So we have this space, the vert is going to flap through, and this value I just found out they work really well by trying an error. We also have to keep in mind that with this setup, the position of the pipe itself is right in the middle, and that will be really important later when spawning. So since we have two sprites, we will also need two collision shapes. Let's also rename them to shape top and shape bottom. And let's assign to both a rectangle shape. And for the extension we will set half of the size of the sprite. So that will be 26 divided by 2 and 160 also divided by 2. And we're going to place this one at -101 like the sprite, and the same for the size of the bottom shape, but placing it at 101. And let's save this scene as pipe.tscn. Next step, the pipe spawner. Let's create a new scene and add a node 2D and also a simple node. Let's name them spawner pipe and container, and save it as spawnerpipe.tscn. So the spawner pipe is going to be similar to the spawner ground, but it's going to start at the right of the view, plus half of the pipe width. Now we can't just move the spawner horizontally and then create a pipe, because it'll be really out of place. So like the spawner ground, when we move this spawner, we're going to set a random Y position. And I have found that at the beginning, we'll have to spawn and move the spawner 3 times to fill the view, so the spawner doesn't instance a pipe within the view. And then, just like the spawner ground, when a pipe's position is less than the camera's position, that pipe will get destroyed, notifying the spawner, which will then spawn another pipe, and that is going to keep happening on and on. So back to the editor. Let's add a script to the spawner pipe, saving it in the scripts folder as spawner pipe. I'll delete the comments. And let's create the functions spawn pipe and go next position. And similar to the ground spawner, we will have a reference to the pipe sim using the preload function. So in the spawn pipe function, we're going to create an instance of the pipe sim. Then we will set the new pipe's position to the position of this spawner. And finally, we're going to add the new instance as a child of the container node. If we call this function on the ready function, we see the pipe right here, but we want it at the right of the view. And we can't just set the position of the spawner here in this vector because the Y position is going to be random. So I'm going to create a function named go in its position that we will call in the ready function. And in this function, we will declare a variable name in its position equals to a vector 2. And at the end of this function, we will set the position of the spawner equals to this variable. So, as I said before, the initial position is going to be the width of the view plus half of the pipe width. So we will say in its position dot x equals, and to get the size of the view, we have to get the viewport rect, and from the rect we want the size dot width plus the pipe width divided by 2. And let's create a constant pipe width equals to 26. Which is the width of the pipe sprite. So for the Y position we will have a random value, and let's say that this blue area represents the random range of the Y axis. If the random range goes from the top to the bottom of the view, it could happen that the random value gets over the ground area, and the pipe gets really out of place. So in our range, we'll have to take out the grounds. But even though this won't be enough, because if the position gets 2 at the top pipe is going to be out of view. And the same if the position is 2 at the bottom. So besides of the ground, we will have an offset at the top and at the bottom to prevent this of happening. And we will have the Y position from this range. So the range is going to be from 0 plus the offset to the view height minus the ground height minus the offset. So back to the editor, the init position.y is going to be equals to random range, and this function is asking for two values, from and to. For the from value, we will pass 0, meaning the top of the view, plus offset y, which is a constant we're going to define here. And I will set it equal to 55. Which is a value I have found out works really well. And from the to value, we will pass the view height minus the ground height minus the offset y. And we don't have the ground height in this script, so let's declare it equals to 55, which is the height of the ground sprite. And I also have to mention that we need to change the seed the random function uses. Otherwise, the random number will always be the same. And to do this, we just need to call the function randomize. And if we run the scene, we won't be able to see the pipe because it's right out of view. Now for the go next position function, we're going to do the same thing as the go in its position function, except for the x value, because we don't want it to be at the same position. So the distance between each pipe is going to be half of the pipe width plus an offset that we're going to set plus half of the pipe width again. So let's define the offset x as 65. And the init position.s is going to be equals to pipe width divided by 2 plus the offset x plus pipe width divided by 2. And let's also remember that the next position is always relative to the current position. So init position is going to be equals to get position. And instead of setting a new x value, we will add it to the current one. And by the way, calling this initial position here doesn't make too much sense. So let's rename it to next position. Now just like we did in the spawner ground, we will need an amount to fill view. I'll set it to 3 because that's enough to fill the view. And on the ready function, after going to the initial position, we're going to spawn and move as many times as the amount to fill view. And we haven't created this function yet, so let's do it below go in its position. And this function is just going to call spawn pipe and go next position. So let's make an instance of the spawner pipe in the game stage to see what we have so far. And we can see that we have 3 pipes, but the pipes should be below the ground. So let's go to the pipe scene and change the z-index of the main node to -1. Now the z-index of the sprites is 0, but is relative to the parent, which is -1. And this at the same time is relative to its parent, which in this case is the container in the spawner pipe scene. But this is just a simple node. It doesn't have a z-index, so at the end the z-value is still -1, which is less than the ground's index. Let's run it again. And there we have it. So now we need to make the spawner pipe spawn when a pipe gets destroyed, and we already know how to do that. In the spawner pipe script, after instancing a pipe and before adding it to the scene tree, we're going to connect the signal SC3 to this self node, to the function spawn and move. And we haven't made the pipes destroy themselves, so in the pipe scene, let's add a script, save it in the scripts folder. I'll clean this as always. And this is going to be really similar to the ground script. We will have a node named right as a reference of the right edge of the pipe and a reference to the camera. So let's add a position node, name it right, and place it half of the pipe's width, 26 divided by 2. So in the script we will get the node right. And the camera, since it's not in this scene, we'll use the get main node in utils and get it from there. And let's not forget we need to use the already keyword when we are referring to a node. So in the process function, we will say if the right global position.x is less or equals to the global position x of the camera, we will call the function q3. So we destroy this node. Let's enable the process function. Now if we run this scene by itself, it will give us an error because the camera is null. So just like in the ground script, we are going to check if the camera is null. And if it's so, we are going to return, so this code doesn't run. Let's run the game stage scene. And the pipes are getting destroyed way after they should, and that's because we have to use the get total position function we created. So the camera position comes with the offset. Let's give it another shot. And there we have it. Well, this is gonna be it for this video. We have covered a lot in this tutorial. I hope I have been enough clear. If you have any question, leave it in the comments. I will be happy to answer all the questions. You can also download the project files. There is a link in the description. And if you like this video, subscribe to get notified about future ones. There will be more. And you can also follow me on Twitter to know what I am up to. And until next time, see you later.